Okay, now we're going to look at how we can use synthetic division to help us solve some polynomial equations. First, we have a few theorems we're going to be talking about, and you can go to your ebook and my math lab. You can go to course contents, find your book, click on section 2.4, and actually read more about the theorems in the book. I've just kind of summarized them a little bit here on the videos. The first one we're going to talk about is the remainder theorem. It says if a polynomial f of x is divided by x minus c, then the remainder is f evaluated at c. So we could go back, look at some of the problems we've done up here, and if I took this function that I divided here and evaluated it, plugged in my c value, that would give me what my remainder is. Okay? So if I look at my example 5, it says, it actually says use synthetic division and the remainder theorem to find the indicated function value. On the homework, they just want you to evaluate f at -2. Okay, so if I plug in f at -2, then I could summarize this. This would be 2 times -8, -6 times 4, plus 6 plus 15. So I would have -16 minus 24 plus 6 plus 15. Okay, so that would give me a -40. And then this would be a positive 21. So that would be, if I subtracted those, would be a -19. So that lets me know that the remainder, if I were to divide by x minus c, or x minus a -2, that my remainder would be -19. Okay, if my remainder is 0, then that would let me know that my polynomial x minus c would be a factor of the original polynomial. Okay, that leads us to something called the factor theorem. So that's on the next page of the notes. The factor theorem says, let f of x be a polynomial function if f at c equals 0, then x minus c is a factor of f of x. So again, this just means if you plug in, you get a remainder of 0, then x minus c is a factor. And then the converse is true. If x minus c is a factor of f of x, then f at c must equal 0. Okay, so the problem says use the factor theorem to solve the polynomial equation. If I'm going to solve it, I want to find every value of x that would make the equation true, or every root or 0 of this function. So it says use synthetic division to divide. We're going to divide by x plus 7. So that means I would have -7, list my coefficients, which would be 1, 15, 71, and 105. There's nothing that's been skipped. Bring down the first number. Multiply would be -7. That would be 8. Multiply would be -56. And then subtract. That would be 15. Then multiply, which would be a -105. And I get a remainder of 0. Okay, if I get a remainder of 0, then that means that x plus 7 is a factor to this polynomial. So the polynomial that I have left here when I divide, which is x squared plus 8x plus 15, is also a factor. So I could take my original polynomial function, if I wanted to solve it, we would set it equal to 0. But now I can break this down into the product of my two factors that I have, which would be x plus 7 times x squared plus 8x plus 15. And so now I have this trinomial that I can factor pretty easily. If we break this down, it would be x plus 3 and x plus 5. And then I just set each factor equal to 0. So I would get x equals negative 7 would be one solution, x equals negative 3, and x equals negative 5. As far as your solution set on the homework, I think they already have the braces and they just want you to type in what your solutions are. These are all the real roots of the polynomial function that was given.